Hello, wonderful person. It's Anton. And today, we're diving into a truly fascinating, and dare I say, a little bit mind-bending discovery that's emerged from Princeton University. It all started with researchers trying to prove something wasn't possible, only to find out it might actually be. We're talking about the potential to generate electricity from the very spin of our planet itself. A concept that, while not producing vast amounts of power, is incredibly exciting if proven to be accurate. Let's break down how this intriguing idea works. The core principle lies in the subtle differences between Earth's magnetic field and its rotation. You see, its spin isn't perfectly aligned with its magnetic field. Earth has two distinct axes, and the magnetic axis is tilted about 11.5 degrees from the rotational axis. This means the magnetic poles and the rotational poles aren't in the exact same spot. Furthermore, we know magnetic poles aren't static. They drift over time. This slight misalignment in specific locations means that as the Earth spins, there's a subtle interaction with the magnetic field. For a long time, physicists pondered if this interaction could be harnessed to generate electricity. In 2016, Christopher Chiba and Kevin Hand explored this mathematically, suggesting it was likely impossible. Their reasoning was that any electron nudged by the Earth's magnetic field would likely rearrange itself, canceling out any potential charge difference. In essence, any attempt to create an electric field from this motion would likely just dissipate, producing nothing. However, their paper did note a potential exception. Under very specific conditions, with particular materials and shapes, it might be possible to capture some energy. Back then, this was purely theoretical, and many studies echoed the sentiment that generating voltage was improbable due to the self-canceling electron effect. But that tiny exception sparked curiosity. For the past 9 years, researchers have been driven to explore if, by creating a special kind of shape, this energy capture could indeed be realized. In a recent study, Chiba, Hand, and Thomas Shea revisited this question, aiming to see if they could prevent that electron cancellation and actually capture a voltage. And remarkably, appears they've succeeded. They've managed to observe a continuous voltage, seemingly appearing from nowhere under various conditions. So, what did they do? Their device wasn't overly complex. It was essentially a cylinder, but made from a very specific material. They used manganese zinc ferrite, chosen for its low magnetic Riot number, which encourages magnetic diffusion and prevents magnetic fields from being overly constrained within the material. This cylinder, about 29.9 centimeters long, just shy of a foot, was then positioned at a precise angle, 57 degrees, in the north-south direction, oriented perpendicular to both the magnetic field and the rotational field, with electrodes placed on either side to measure voltage and precautions taken to eliminate external disturbances. They detected a small, but measurable voltage, approximately 18 microvolts. Now, it's natural to wonder if this could be attributed to other known effects, like the Seebeck effect from temperature gradients. To rule this out, they conducted further tests. They replaced the cylinder with one made of a different material and altered its orientation by 90 and then 180 degrees. In these instances, the voltage vanished. Crucially, when rotated 180 degrees, the voltage reversed. Repeating the experiment in a different location yielded the same results, strongly suggesting this wasn't a fluke. This is where things get truly exciting. The source of this voltage remains uncertain, but its behavior aligns with the predictions from the 2016 study, pointing towards an interaction with the magnetic field. It's a strong possibility that they've tapped into a form of free energy generated by our planet's rotation. The researchers themselves are being exceptionally cautious, and rightly so. They're encouraging others to replicate their findings, to explore alternative explanations or phenomena not yet considered. It's a reminder that science thrives on rigorous testing and diverse perspectives. For instance, could it be an unexpected capture of nearby Wi-Fi signals? While unlikely, it highlights the need for thorough investigation. Theoretically, it now seems possible to generate electricity using specific cylinders made from particular materials, oriented to interact with Earth's magnetic field and rotation. This challenges their previous conclusion that no stationary conductor should generate power from a magnetic field. However, the most significant caveat is the minuscule amount of voltage produced, about 1,000,000 times less than what's needed to charge a smartphone. While theoretically, 1,000,000 such tubes could charge your phone, the practical reality is that even if this phenomenon is real and capturable, its efficiency might be too low for widespread use. We've seen similar ideas, like piezoelectric sidewalks or thermoelectric generators, that sounded promising, but ultimately weren't efficient or cost-effective enough for significant energy generation. So, the conclusion is that even if this discovery is valid, scaling it up for industrial use, or for powering our homes, remains highly uncertain. It might find niche applications in specialized sensors, but widespread, free energy is likely still a distant prospect. Nevertheless, from a scientific standpoint, this is a remarkable discovery. A simple cylinder, interacting with our spinning planet and its magnetic field, generating electricity. It's important to note this works with relatively weak conductors, essentially acting as a magnetic shield. This discovery also brought to mind the intriguing resonant cavity thruster experiments from around 2013 to 2014, often referred to as the M-drive. Those experiments also detected a tiny, yet present, thrust that was potentially generated electromagnetically. It would be fascinating to explore if these two phenomena are connected, perhaps suggesting that some of the previously unexplained results in those experiments were related to magnetic field interactions that were overlooked. For now, we can only speculate, and future studies will undoubtedly shed more light on what's truly happening. Thank you so much for joining me today. If you found this exploration of science and space as captivating as I did, please consider sharing this video with someone who might enjoy it. Come back tomorrow, and let's learn something new together. You can also support this channel by joining our membership or by checking out the Wonderful Person t-shirt available in the description. Stay wonderful, and I'll see you tomorrow.